Let me do this integral by three methods, three different methods. Method 1, I let this x be negative t. Then my integral will be from positive a to negative a, right? Log absolute value t squared plus 1 minus t, and then negative dt, right? Okay, then I change this negative to flip. No, it's interchange the limit. Therefore, this one is equal to negative a to positive a, right? So negative is gone. So the dummy variable, I rewrite this for x. So this is equal to x square root x squared plus 1 minus x dx. All right, so this is I. This is also I, right? Therefore, 2I is equal to this plus that. From negative a to positive a, the log absolute value x squared plus 1 plus x plus log absolute value x squared plus 1 minus x, right? Altogether dx. Okay, that's good. Then 2I is equal to negative to positive a. This will be by a property of log, and then you multiply these two together, right? This means log absolute value x squared plus 1 plus x multiply by that root x plus 1 minus x, right? Here, I simply multiply these two together, then take log. So this is from a to a log. This is squared, x squared plus 1 minus this x squared, right? dx. So this one is equal to from a to a log 1, right? dx. Log 1 is 0, so that's a 0. So my integral I is equal to 0. Okay, this is method 1. Now, method 2. Method 2, let me use a different color, okay. Let me use a conventional method, which means from a to the log. Let me go slowly. This method is a little complicated. Plus x, right? And dx. Okay, that's the integral. Now, method 2. I'm using by parts. By parts. Okay, I'm using by parts. By parts. By parts, this is a u, right? This is a u. Log this altogether is a u. And dv, v is x. So this one is equal to uv. U is this, log absolute value x squared plus x plus 1 plus x, right? And together multiply v. V is this. Then from minus a to a minus v du, integral from minus a to positive a, v du. V is this. V is x times du. du is the derivative of this log, right? This is the derivative, so equal to x squared plus 1 plus x. Then on top of derivative will be 2 square root x squared plus 1 chain rule, right? 2x, yeah, and plus 1, right? v du, yeah, dx. Okay, this is my u, this is my v. V times du. Du is this. Then simplify. This one, it will be log a square plus 1 plus a multiplied by a, right? Yeah, minus log absolute value a squared plus 1 minus a multiplied by negative a, right? That's it for this one, okay? Then minus integral from minus a to positive a. This will be square root x squared plus 1 plus x multiplied by x, okay? This one is to simplify this one, I multiply by numerator and denominator by square root x, right, times the square root x squared plus 1. So this is gone. So you have x plus square root x squared plus 1, right? Well, so far so good. Well, let's say good. So this is equal to, now this is a, and a is a common factor, so a is out. This negative changes this one to positive, so it becomes a log. This added this becomes a square root a plus 1 minus a plus a multiplied by square root a squared plus 1 minus a, right? Okay, so negative become plus. Log a plus log b equals log a times b. So log a times b. Okay. And minus. Now, I forget take a negative a. No, this is have already take. No, I don't need it. Okay, now, second part. This part is, I simplify it, minus, from minus a to positive a. And this one is equal to x squared plus 1, right? Plus x square root x squared plus 1. So this one times is x squared. This one times this one is plus x times dx. Yeah. Okay. Now here I'm adding 1 and minus 1, right? The reason obvious that this over this will become a 1. This over that is another integral, right? So let me continue. Here, the a multiplied by log this times this one becomes a squared plus 1 minus a squared, right? Okay. Minus that one. This one is equal to from minus a to a. This becomes x, right? Yeah, no, dx. And then minus become plus from minus a to positive a, and 1 over x squared plus 1 plus x squared root x squared plus 1, so dx. Wait a minute, this is minus, become plus, no more bracket. Okay, so far so good. I hope you can follow my very messy writings. All right, so far so good. This one is a multiplied by log. This time this one is a squared plus 1 minus a squared, right? Yeah. So minus this one, right? Yeah, this is this one is 2a, right? A minus a is 2a plus integral minus a to a dx plus 1x plus x squared plus 1. Okay, so this is 0. This is 0. This is 0. Because log 1 is 0, right? Okay, this one is a 2a, minus 2a, plus this I, say I1. I call this as I1, right? All right, so my I is equal to this. This is 0, this is 2a, minus 2a. This one I need a further discuss. So, all right, let me continue. This one. For I1, I let x be tangent theta, right? So dx is equal to secant square theta d theta. So my I1 is equal to integral, right? X is equal to negative a, x equal to a. I don't convert a to theta, I just keep as x. So this one is equal to secant square theta d theta. X squared plus 1 is a tangent square plus 1 is secant square. And plus x is tangent theta. X squared plus 1 is tangent square, plus 1 is a secant square. Take square root of a secant. So secant. Okay. Then this one is equal to x is negative a, x equals positive a, divided by secant. So secant theta d theta. Divided by secant, because secant is gone, right? By secant is tangent. So my I has been simplified into this. Now from here onward, I think is rather easy. I multiply I multiply by secant plus 10. X equal to A, right? And times secant theta plus tangent theta multiplied by secant minus tangent. Alright. This one secant theta times secant theta minus tangent theta, d theta. Okay. And this one equal to x equal to negative a, x equal to positive a. This would be the secant square minus tangent square. On top will be secant square minus secant tangent and d theta. This will be x equal to minus a to x to positive a. Well, this is the 1, right? Secant square minus tangent square is a 1. So you have a secant square theta minus secant tangent theta d theta. Now, the first integral is tangent, right? So, is tangent theta. That integral is tangent theta. That integral is secant theta, right? And x equal to negative a to positive a. Yeah. Now, continue. As we know that we have an assumption from beginning that is theta, right? Tangent theta is equal to x. So this is x, right? This is 1. So this is x squared minus plus 1. So we have the I1 is equal to tangent theta. Tangent theta is x. Secant theta. Secant theta is this over that, right? So this is x squared plus 1. Now from minus a to a. So this one is a minus a squared plus 1, right? Minus a minus a squared plus 1, right? So this is going to be cancelled. This is being 2a. So my I1 is 2a. Then I say, therefore, my I is equal to minus 2a plus 2a is equal to 0. So my integral from beginning, that integral is 0. Okay, that's method 2, which is quite long. Method 3. Method 3 is very simple because look, this is the integral, right? A to a log square root x squared plus 1 plus x dx. Now, method 3, we don't even have to integrate. We know this is right away is 0. You know why? Because this function is odd function. If this is odd function, integrate from negative a to positive a is 0. Now, how do we know is the function is odd? Well, of course, we can verify it, right? We suppose that f of a equal to log square root x squared minus 1 plus x. Okay. Yeah. And then f of a negative x is equal to log x squared plus 1 minus x, right? Then f of x plus f of a negative x is equal to this plus this, right? This is a log this plus x multiplied by square root x squared plus 1 minus x. Yeah, so this was the log x squared plus 1 minus x squared, right? So equal to log 1 equal to 0. Therefore, function is an odd function. Odd function that f of x plus f of a negative x equals 0. That's odd function. Okay, that is very easy to prove. And or you can use this one. F of a negative x is equal to log x squared plus 1 equal to, that's f of a negative x, right? This is equal to, you multiply by denominator by a numerator, okay? This one is equal to x squared plus 1 minus x multiplied by square root x squared plus 1, and also x squared plus 1 plus x, right? So this is equal to, this is a long one, right? This is a x squared plus 1 plus x. So this one is equal to, this one is equal to log x squared plus 1 x negative 1, right? So that's equal to negative f of x. So f of a negative x is equal to negative f of x. So f of x is odd function, all right? So therefore, this integral is 0. We don't even have to integrate. Okay, so we have done 3 methods. Well, the easiest method is that not integrate, just write a 0 by claim that the function is odd. Okay, thank you for your watching.